Welcome. This is the Quintessential Home Network Component Primer for people who like the internet. Do you like the internet? Learn enough to have an informed conversation with other people about networking components. Alright, so first on our list is a modem. A modem modulates and demodulates signal from one protocol to another. Typically on your network, it's going to speak Ethernet, and then your ISP is going to use something like VDSL or DOCSIS if it's over a cable modem. A modem basically, it just translates your network to whatever your ISP speaks on their network. Now, if you live in a place with competent governance, then you should have fiber to the home rather than some sort of modem over retrograde cabling. If you've got fiber to your home, then instead of a modem, you've got an optical network terminal, or ONT for short. You've got this and not a modem because fiber technically is Ethernet the same way that four-twisted pair, the copper Ethernet that everybody thinks of when we say Ethernet. The Ethernet, the protocol, is exactly the same across both of them. So you don't have to translate from one language to another. So it saves a little bit of steps and time and cost savings as well. Media converters are fairly simple and cheap in comparison to something that actually needs to interpret what's going on instead of just turn the pulses of electricity into light and light into electricity. Now, the router is basically the brain of your network. That's kind of the simple way to interpret it. It's in charge of handling the paths into and out of your network, as well as some of the behavior and services inside of your network. Typically, in the vast majority of networks, the router is also running the DHCP service and handing out IPs to devices that ask for them when they join the network. It can do a whole bunch of other things besides, but for a definition of the device itself, it really is just handling connections into and out of your network, as well as some rules of behavior inside of your network. Now, a switch controls local-to-local Ethernet traffic. If you have two computers on a local network and you transfer a gigabyte file from one to the other, it will go through the switch and not even bother the router because it knows it's local traffic. Besides that, the switch is also bridged to the router, so anything you plug into the switch is effectively, logically speaking, like it's plugged into the router directly. And as far as the average person needs to understand a switch basically works like a power strip, but for Ethernet instead. Like you use a power strip you plug into the wall to get more plugs than you have on the wall. A switch is basically the same thing for a router, where if the router had infinite ports on it, we just plug in directly to that, but you can't just, scale infinitely with that. You can keep putting in more switches and stuff, and that's how you get more ports. So that's what a switch's purpose is. It's just to get more ports for Ethernet. A wireless access point is a hardware device that has a transceiver in it used to communicate with wireless client devices. Besides the hardware level radio-to-radio communication that the access point enables, it also has a chip in it responsible for encrypting and decrypting all of the traffic sent between it and the clients attached to it. In layman's terms, a wireless access point makes Wi-Fi happen in a bubble around them, in which when you're in that bubble and have a client device, you can connect to Wi-Fi. Now, an ISP gateway is a device that your ISP will give you. If you just call up and say, hey, I want an internet service, they'll send a tech out and he'll install one of these devices. This device is a jack of all trades sort of device that is a modem, a router, a wireless access point, a switch, and typically a voice over IP gateway, so they can sell you a home phone as well. They put it all in one box, so it's nice and easy for them to troubleshoot. You don't have to have a whole bunch of boxes all over wherever you install this thing, and it's very simple and cheap for them to maintain. It's great for them. The problem is that they don't really care about how well your home network performs. They don't have to deal with it. In fact, the less sort of data you take up, better for them ultimately. So their goal literally is to build this thing as cheap as possible without you calling support all the time. That's their goal. Well, and then to rent you the device for $10 a month or $15 a month or whatever they can get away with. That's just like free money. Also, fun fact, they probably use it to spy on you. They say they can collect usage data, and if they are actually acting as your router, then they can see a whole bunch of data that they otherwise couldn't if all they were sending data to was a modem. A client device is basically any device on your network that isn't network infrastructure itself. The computers that you want to give service to, cameras, phones, your thermostat, some sort of smart plug, anything like that that you attach to your Wi-Fi, all of those are client devices. A switch, the modem, router, all of that is infrastructure. All right, let's take a look about how these devices interact in a real logical network diagram. So we've got the internet where all the cool things are and we want to get to it. How do we connect to the internet? Well, unless you've got a data center and peering arrangements with other giant ISPs and providers like Level 3 Communications or something, then you're pretty much stuck with paying an ISP for the privilege of connecting through their network. Your ISP connects to the internet and then picks a protocol, or if it's fiber, then they run fiber to your house and you get an optical network terminal. But most of the time they're going to run it over coax, or they're going to run it over the old phone lines, and you're going to get DSL or DOCSIS and out to your modem. The modem is the first step in this diagram that you can actually control and own. You can purchase your own modem and decide to get a good one or not, or use one of the gateways from your ISP. From the modem, we go to the router being the brains of your network and deciding what goes up and down through the modem. A switch connected out to that router to enable more Ethernet ports as well as local-to-local traffic. If you've got a bunch of cameras or computers locally, transferring stuff locally, it all stays on the switch, doesn't have to bother the router at all, and the router can just focus on exterior connections and whatever protocols and services it's running. From the switch obviously enables you to plug in all the wired clients, and then you can plug in also wireless access points into the switch. Wireless access points, typically 2 or 3, will cover a house pretty well these days. And then through the wireless access points, we connect to all the wireless clients. And then beyond this, if you just call up your ISP and say, hey, come give me internet, they'll come bring their ISP gateway in. They're in control of that. Essentially, you don't really have much control. You can change the Wi-Fi names and passwords and stuff, but you don't functionally have a whole lot of control over your network if you're using their gateway. So it makes it a very simple network diagram. It's just one you don't have any control over at all. Now, there are several reasons why I prefer to have separate devices for each function of the network. First off is if you've got them in separate devices, then each device has dedicated hardware and processor resources to handle its one purpose. If they're single purpose devices as well, then whoever designs them only has to design for a single function. So it probably will perform that function a lot better than something that is trying to do 4 or 5 things at once. If every device is a separate device, then it becomes relatively easy to troubleshoot any problems with your network infrastructure. You can plug a laptop directly into the modem and see if internet is coming in or if there's some problem on your network equipment. If you get internet on the laptop, then you know it's some problem in your network. If you don't get internet off the laptop, you know you can yell at your ISP. Another great feature that most people don't think about is if they're separate devices, then the only device that you really care about the actual physical location of it is the Wi-Fi, because Wi-Fi devices need to be in proximity to it. Otherwise, you can hide most of this stuff in the basement or a closet or an insulated attic even. You can hide it pretty much anywhere. It doesn't need to be out and stuck cluttering up a living space. Another great advantage are targeted upgrades. You don't need to swap out switches and routers and the cable modem every time the Wi-Fi updates, which that's the thing that changes the most. If you want the new version of Wi-Fi, you just get new access points and everything else can be left in place. So there you have it, a quick primer on the basic networking components. I hope you learned something. See you next time.